Good afternoon, and thank you for joining the webcast today entitled How Hyperconverged Hypersecure is Your Organization. I'm Michael Rothschild, your host. We have lots of good content for you today that will undoubtedly bring new questions to the table, as well as hopefully answer some of the questions that you may already have. It doesn't matter what business vertical you're in, but we're all faced with the same challenges in terms of your infrastructure and, of course, your security. Today, I am joined by our speakers, Amit Jain, Senior Product Manager at Nutanix, and Arun Gowda, Vice President of Business Development at Vormetric. Thank you, gentlemen, for joining us. A couple of quick housekeeping items before we get started. All of your phones have been put on mute to ensure the quality of this broadcast. If you have any questions, you can type them in the Q&A section of your user interface. I'll hold them, and we'll have lots of time at the end for question and answer. If for some reason you need to leave the webcast or would like to share the information with others, this webcast is being recorded and will be available for replay after we wrap up. And you'll be getting an email to that effect with all of the information as to how to download materials as well as how to listen to the replay. So for today, we're going to cover a couple of different areas, and the agenda for today is to kind of talk about some of the trends and needs, some of the things that are keeping you up at night, as well as today's paradigm, both on the infrastructure side and the security side. Of course, you'll hear from our presenters about Nutanix and Vormetric, but more importantly, how together as a joint solution you can achieve hyperconvergence and hypersecurity. We'll have a summary at the end and, of course, give you a bunch of resources to follow up with. And without further ado, let us get started. I'd like to introduce you to Amit Jain. Sir, please proceed.
Thanks, Michael. Well, before I talk about the data center, hyperconvergence, and hypersecurity, I would like to take a step back and talk about how our normal day-to-day life has been made simple by technology disruptions. Well, most of us are always on the go, and taking cab has never been so easy with Uber, Lyft, and like companies. Now it is very well known how much disruption those companies are bringing to the taxi cab industry. However, a very important point to reckon is that Uber is not a cab company. So what is Uber? What are they? And the more you think about it, the more you realize that they are a technology company armed with a new business model. So here you see a trend. A company using IT systems expertise to disrupt something as mature as the taxi cab market. And this is not the only vertical. This trend is becoming ubiquitous. You look at LendingTree, what it is doing to the banking industry. You look at Airbnb, what it is doing to the hotel industry. And the common tenet is that technology is increasingly becoming a strategic enabler in every industry. And business leaders, they see this and they want technology platforms that can enable new business models quickly. And this is what attracts the business leaders to the public cloud. When they look at AWS offerings from Google or Microsoft, what attracts them is the agility, elasticity, and cost transparency. No longer they have to size based on what their future needs could be. They can easily spin up or spin down based on their current demands and can figure out very easily what are the cost economics of running those workloads or scaling them up or scaling them down just at the point of a click. So it's very, very simplistic consumption model that everybody well understood, and it is very keen on latching onto. However, the public cloud is not free of its own, it's not a free lunch. It does come with a set of concerns, and the concerns are more around the control, customization, and data privacy. If you have your on-prem data center infrastructure, you are very much in control, and you can provide tighter SLAs to your respective businesses. So you are in a complete control of that infrastructure. More importantly, if there are certain legacy workloads that need customization, you can have a specialized infrastructure in your data center versus a cookie cutter approach that's provided in a public cloud model. So it provides you that kind of authority and leadership that you can command onto your infrastructure. And more importantly, it's about security and data privacy. Well, there are certain industries where you cannot move to the public cloud because of data privacy and security reasons. And Arun from Vormetric is going to talk about it in a few minutes. But those are the very key concerns that business leaders have when they move to a public cloud infrastructure. And at a high level, that is the infrastructure dilemma. The traditional infrastructure is letting the customer choose between the two ends of the spectrum. Ideally, you want to have both. And that's the promise of hyperconvergence. And we at Nutanix pioneered that concept, and we are going to go along and talk about how we are simplifying the data center to make the consumption model still cloud-like, but still make you in control of that infrastructure. So with that, let me pass it over to Arun and talk about why security and data privacy is so important. Over to you, Arun.
Great. Thanks, Amit. Hi, folks. This is Arun Gowda from Vormetric. Yeah, so first let's address why data security and privacy is important, specifically as it pertains to sensitive data. I mean, sensitive data is proliferated everywhere in a company, and a hyper-converged infrastructure like Nutanix is no exception. And if you think about sensitive data, what types of sensitive data are out there? So, for example, it could be patient health records, personally identifiable information, intellectual property, customer private information, just a whole host of information that can be considered sensitive. And this sensitive data is typically under a couple of governance mandates. So first is, if you think about compliance and regulatory requirements, so think of PCI or HIPAA or state regulatory requirements around protecting that sensitive information. That's one of the things to consider and why it's important, because you're going to have to meet those requirements, or else either pay a penalty or not be PCI compliant, et cetera. And the other one to think about is, as we've seen some recent headlines, there's a lot of information out there that's very valuable, and so folks like rogue insiders want to steal the information, as well as malware and APTs that somehow find a way to get into your company. They'll exfiltrate sensitive data and use that for espionage purposes or to extract value from that information. So you have to protect yourself from those types of attacks as well. So on the one hand, you need to meet all the compliance and regulatory frameworks you've historically have had to meet. But on the other hand, what we've seen, again, we've seen in quite a good volume over the last year, is you have to be able to protect yourself against data breaches. And this includes both, again, rogue insiders or malware and APTs that are trying to steal that data. And again, it's not all of the data they're after. It's really the sensitive data, PII, PHI, et cetera. So we have to make sure that we're conscious of this and thinking about ways to protect that data. So now I'll forward it on to Amit. Oh, I'm sorry, this is me again. So what are some of the ways that folks are looking to protect data? So the first is, one of the things that is gaining popularity is encryption. So encryption's been around a while, but as you can see, there was a Ponemon Institute study that was done, and encryption is increasingly a way to protect that sensitive data from both prying insider threats and external threats, as well as being able to adhere to compliance requirements. And to kind of underlie that also is another study that was done by IANS, which showed that 84% of companies were implementing an encrypt everything strategy, or encrypt all sensitive data. So again, sensitive data is sitting out in various places, including hyperconverged infrastructure, and companies know that any one point of vulnerability could be a place where that information can be compromised. So increasingly, folks are looking at encryption, and again, because they don't want to be the next headline, or they want to conform to regulatory requirements. So Amit, I'll pass this on to you now.
All right, thanks, Arun. So we talked about what are the trends and the needs happening in the data center infrastructure, And now let me take a deep dive on explaining what is hyperconvergence and how Nutanix is trying to solve the complexity in the data center. Well, if you look at the traditional stack that exists in the data center, it's three-tier. You have the networking layer from the likes of vendors, for example, Cisco, HP, Arista, Brocade, or Juniper. And then you have the servers from HP, Dell, Cisco, or Lenovo. And you need the networking glue, which is a specialized networking glue, but before you connect, you need that networking glue to connect to the storage arrays. You have it from the likes of EMC, NetApp, HP, Dell, or Hitachi. And then comes the networking substrate to connect those servers to those storage arrays, and these are fiber channel switches from Cisco and Brocade. And that's not it. You need specialized adapters from QLogic, Emulex to make this functioning happen. So as you can realize, there are multiple vendors, multiple devices involved in spinning up this data center infrastructure. And the reason why I'm bringing this up is because these are very specialized pieces of equipment, things that are so complex that independent companies exist to satisfy the need at each tier. And that's not it. That just constitutes your physical infrastructure. Building on the top of that, you need to have a virtual infrastructure, be it from VMware Hypervisor or the Microsoft Hyper-V, before you can finally go to the app layer, which is where the true differentiation that you as a business can bring to the market. And those applications could be from Microsoft, Oracle, or SAP. But those are the key things that you really want to focus on and see from this picture the kind of layers that you really have to build on to really spin up that application. So, I mean, and I would like to draw a parallel with the converged systems like FlexPod or vBlock that exist and that try to provide that kind of convergence. But essentially, their stack also looks exactly like is shown in this picture. It is an old stack. What they tell you is that that particular switch would work with that storage array and with that firmware and so on, so that you can deploy with a peace of mind. But essentially, there are still silos in your organization. There are still multiple vendors. There are still multiple storage devices that adds to the complexity. And what you really want to focus on is the app that really matter to your business. And it is this complexity which can lead to this reality. And it's not about what something is gone wrong in the data center or somebody is trying to do something wrong in terms of misconfiguration or whatever. It's merely an expression of the complexity that exists in the data center. And how hyperconvergence can solve it, let's look at it. So you definitely need networking infrastructure, 10 gig in networking infrastructure from your favorite vendors like Cisco, Arista, Brocade. And we at Nutanix have converged the storage networking, and the storage array layer into one single box, which is Nutanix, so that the physical infrastructure that you need to have is minimized to absolute minimum. And on the top of it, definitely you need a virtual hypervisor layer, which either could be from VMware or Microsoft. And what we have done at Nutanix is that we have also stepped into the hypervisor boundary and tried to make it simple so that you don't have to worry about what's running underneath your applications. You can just deploy your applications in a cloud-like model without caring what's running underneath, because we at Nutanix would provide that SLA that your applications are looking for. And this is the kind of simplicity that we have brought to the data center. And most importantly, Nutanix architecture is a scale-out architecture which allows you to start small with a single cluster of, let's say, 3 nodes, and you can scale it forever depending upon how your workload is scaling up. And most importantly, the scale-out architecture abstracts out the pool of compute and storage So it provides a consumption model which is simple and cloud-like, thus providing a truly invisible infrastructure so that you as a customer can focus on the business applications. And this invisible infrastructure has built-in security. And the built-in security is based on three tenets. The first is about self-healing and host security. We have made sure that Nutanix architecture, Nutanix boxes are hardened by default, and it incorporates Nutanix-defined strict baseline, which exceeds the security baseline as set by Department of Defense. And most importantly, what you want to make sure that your system is secure going forward, not at just one point in time. So our system have a self-healing framework which utilizes the salt stick thing to identify any deviation from that baseline, and the system would self-heal itself. So at any point in your system would be compliant based on the settings, based on the baseline that was set a priori. And that is very, very important as you progress in your data center journey evolution. And the second thing is about security forensics. We provide a real-time situational awareness of the threat landscape in your data center and try to simplify the root cause analysis and provide you some insights of what's really happening in the data center so that you can analyze and try to mitigate that risk. And the third point is about the data security, and which is where we partner with vendors like Vormetric to provide that kind of resilience and security to the data center infrastructure. With that, I will pass it on to Arun to talk about how we are leveraging that partnership and trying to unleash the security to the data center.
Thanks, Amit. So let's look at, so how do we encrypt? So there's essentially two categories of encryption, and we'll focus on one, but we'll talk about both up front. So one is data in motion, so encrypting between devices or as data is being transported from one device to another. And some typical ways to do this is SSL, SSH, IPsec, etc. And this is really data in motion. But the context where we're going to be talking about today is protecting data at rest, because this is really the place where most of the breaches are happening when data is at rest. The data is being stolen or being compromised. So let's look at some of the various ways that we protect data at rest. And if you look at a traditional stack, you have the application / database, you have a file system, and you have a disk level. And so essentially what we'll do is look at various techniques to protecting that data in that stack. So again, with this stack in mind, typically there's two trade-offs you're going to make when you're thinking about how do we protect and encrypt this data. So one is complexity. How hard is it to implement this? Am I going to have to make changes to my application or database? And then the other one is security. What type of threats and what attack coverage, attack surfaces is this technique going to help me out with? So if you look at this stack, there's actually I'm going to blow this up here. So on the application database side, some very common techniques are field level encryption, tokenization, data masking, etc. And then on the file system, it's file level encryption with access control. And then finally, you have full disk encryption, also called self-encryption drives. These are the various techniques that, again, are used for this stack. And so if we look at the types of threats that these techniques help you protect against, oops, go back one here, apologize. So basically you have, so these are type of threats that these techniques protect against. So if you start from the bottom up, so you have disk level protection or disk level encryption, that really protects against physical theft of the media. So if somebody steals the storage, then it's encrypted and you don't have the keys to be able to unlock that data. And if you look at file level encryption, it really protects you against again, theft of the data as well as the insider threat, the privileged user, and any APTs or malware that compromise privileged user accounts to exfiltrate data. And then up top, you have application database, and this really, some of the techniques we talked about to help protect against this type of attacks really help you against rogue DBAs as well as SQL injections. So if you look at this, again, these are various levels of protection, and really the trade-off is the complexity of the implementation versus how much security you're going to get. So again, if you look at Vormetric, and we actually cover all of these use cases using various techniques. So for application and database, we have field level, app level protection, as well as tokenization. And for file level encryption, we have what we call Vormetric transparent encryption. And then we also do key management for self-encrypting drives of full disk encryption technology, such as the ones that Nutanix has. So essentially, this is our coverage with Nutanix, is both the transparent encryption as well as the key management. And if you look at the file system encryption, and to some degree the disk level encryption as well, these typically cover 90% of the use cases, and that allow companies to really deploy at a much lower cost and complexity, as well as get the most amount of protection out there. And this is what we've seen from our customer set as well. So what I'm going to do on the next couple of slides is go into detail on the transparent encryption product, as well as the key management product as well, and how we help augment the security features of Nutanix. So first, let's take a look at our Vormetric transparent encryption. This is file-level encryption, and the reason we call it transparent encryption is there's no changes to the application or the database. So essentially, it's transparent to the users. So if you look at this diagram on the dotted box here, we actually have a typical workload, and so here you see, and this could be a Nutanix cluster, and it could be a VM running in a Nutanix cluster. And that's in the gray box here. And then if you have three populations of users typically in a company. You have system level users, or sysadmins, or root users, and you actually have business users. So let's take a look at some of the ways that transparent encryption can help work and protect against the threat vectors. I'm going to go ahead and illuminate this slide here. So if you look, so there's two main components of the Vormetric architecture. So the first is our DSM, which is our data security manager, and you can think of it as a security policy manager as well as a key manager, and it houses the keys and the security policies. And the encryption is done at agents that would sit in either virtual or physical servers. So if you think of a Nutanix cluster, it's going to have a bunch of VMs. And so our agent would actually sit at the guest OS of the Nutanix cluster and enforce a security policy. And what does that policy look like? Essentially, there's two main components of the policy. The first is, do you allow access to the data, and do you decrypt the data? So in essence, what you do is, if you look at the population of users out there, so you have privileged users that you allow access to the data so they can do the data management job, but you don't allow them to view the file data. So in effect, you're blinding the data to privileged users, allowing them to do their job, but you're not allowing them to see the file data. And this is really powerful because it helps reduce the risk from root users and sysadmins that, although have a legitimate right to access the data, shouldn't be able to view the data because they're not business users. So this really helps address that insider threat. And then if you have, again, normal business users, DBAs, as well as application users, they're allowed to access the data and view it in the clear. So to them, it's transparent. So when we talk about transparent encryption, they have no idea, honestly, that this is working in the background, because they have completed. This will work like they've always worked for them. And then finally, if this data is out in the cloud, so if this workload could say is out in the cloud, you can get the same level of protection against the cloud service provider admins as well, because they have administrators out there in the cloud. So again, you can explicitly allow define which cloud providers and their sysadmins can either view data or just access the data. And because the keys and the security policy is owned by the company, they have very tight control on, again, who can view and access the data, whether internally in their own data center or externally out in the cloud. And if you look at this agent, again, it's sitting, the reason we call it transparent encryption is it's sitting below the database layer at the file OS layer that's connected to storage. And it's actually looking at every file I/O request and then applying this policy of, do you allow access to it and do you decrypt it? So essentially, it's looking at every, and you can get very granular and define which file directory or array you want to apply this policy towards. So you can have a very tight policy around who can view data and who can actually access data. And from a performance perspective, and this is a common question we get, encryption. People always say there's a price to pay for encryption. And while that's true, the industry's come a long way, especially Vormetric, on optimizing performance. So we actually integrate with the Intel AES-NI chipset that allows us to offload crypto and key management functionality to the CPU itself, and it allows you some dramatic performance improvements. So typically we're seeing single-digit overhead with respect to encryption. And again, it's very transparent to the end users, to the business users as well, that this is happening in the background, and it's giving you a great level of protection. And so essentially, so the other thing that's happening is we're capturing very rich audit data on these users as they come in, and determining who's accessing the data, what they're doing, et cetera. And this is very useful for reporting and security analytics. So we take all this data and we can feed it to the major SIEMs out there, including ArcSight and McAfee Nitro, Splunk, IBM QRadar, et cetera. So you can actually take this data and use it for reporting purposes. So for compliance, you actually can take the data and report against it, against granular file level access of users. And then also from a security perspective, you can, there's two events that are very interesting. So first is, suppose you have a privileged user that tries to come in and escalate their privileges to become a business user. We can detect and block that and send that alert off to a SIEM, because that's typically a security-related event. Or if you have an unauthorized user or unauthorized process that's trying to access the data but they can't, that typically means that, again, some kind of suspicious activity is occurring. We'll fire that data off to a SIEM. So in a nutshell, with transparent encryption, what you're getting is, I got a slide that I'm not familiar with, Michael, on the screen.
Yeah, it looks like the screen is refreshing for some reason.
Okay. So apologize for this. Bear with us for a minute, please. Okay, so I'm just going to keep going in the interest of time here. So essentially, we talked about the transparent encryption and the level. Again, what that's really buying you is protection from system level threats and below. And again, very easy to use. It's transparent, and it's a flagship product for Vormetric, and it gets you three things: encryption, the privileged user access control, and the rich audit log data to apply security intelligence against and look for suspicious data. If you take transparent encryption, one of the other things that this really complements from a Nutanix perspective is the ability to encrypted backups. So Nutanix has a very elegant way to do backup data into the cloud. So essentially, with our transparent encryption agent, what this allows you to do is send encrypted data to the cloud. So if you have a storage administrator that's responsible for backing up data, again, what you can do is they don't see the data, it's encrypted, but they can do the data management job. And because the data is encrypted and they're accessing it, they can actually, when they do the backups, they can send encrypted data to the cloud. So imagine a scenario where you need to back up your data to AWS or Rackspace or what have you. Essentially, that data is encrypted, so you can move from cloud provider to cloud provider without having to worry about data security. And you own the keys and the security policy, so you can explicitly determine when and under what conditions somebody can see that data, including the cloud provider. And the other integration that we'd mentioned with Nutanix was the integrating with their self-encrypting drives. And Nutanix natively, a Nutanix cluster, has the ability to do self-encrypting drives or full disk encryption. And again, this is encryption at the storage level, where it's really the main use case is really good for physical theft. If somebody steals that cluster, they won't have the ability to view the data. And one of the key components of enabling this is the external key manager. So Nutanix, when you turn on self-encrypting drives, you still need an external key manager. And this is where Vormetric can come in. If you remember from a couple slides ago, I talked about our data security manager, or DSM. This can act as an external key manager for Nutanix SED technology. So in essence, you have an external key manager with Vormetric, and we talk to the Nutanix SEDs with a KMIP interface, KMIP, which is a common key management interface. So this allows you to have segregation of duty between the data and the keys, because if the data is compromised, the keys are still stored externally by the data security manager, and so you have a nice segregation of duty there. And again, this is fairly straightforward because we have that KMIP protocol, and this is another technique to do encryption, and this protects you from theft of data as opposed to system level protection against OS users and below. This is really more around theft of the data. So in summary, we have a bunch of good joint information with Nutanix that you can read more about around the two specific use cases we talked about. So first was, transparent encryption, hyperconverged infrastructure with Vormetric transparent encryption. Again, running the Vormetric transparent encryption on the Nutanix cluster itself. And then the other one is secure data access and compliance, and that's where the Vormetric data security manager is acting as a key manager for the Nutanix self-encrypting drives, and that protects against physical theft of data. If you download the presentations, you'll find links to the documentation, or the documentation's available on Nutanix's website or Vormetric's website. And that's essentially the content of the presentation, and we'll open it up for Q&A. And I want to thank you for listening to the content, and hopefully it provided some good food for thought for the audience. Michael, I'll turn it over to you.
So thank you very much, Amit and Arun. Appreciate the time that you've taken to show us all this information. We are open for question and answer at this point. So if you have any questions, again, you can type it in the box, and we'll be happy to answer any questions that you may have at this point. One of the questions that we have coming in right now is just about deployment. How long does deployment of this solution take, and what's involved in terms of personnel that people have to a lot to actually put this in their environment today?
So I can take a stab at one of the two choices that we have. So as Arun mentioned, that there are two choices of providing encryption or data encryption capabilities. One is data at rest, which is provided by the self-encrypting drives within the Nutanix substrate. And you do require an external key management system from Vormetric. And from that point on, once you have the Nutanix cluster, you have the SEDs already. And with our simplistic GUI interface, which we call as Prism, you just enable that encryption feature, and you exchange few certificates between the KMS and the Nutanix cluster within few clicks. And once that's done, a trusted relationship between the KMS and the cluster is established. And When the Nutanix cluster boots up, only at that time it contacts the KMS to get the keys to unlock the drive, and from there onwards, the data, whenever it's getting written to the disk, it's always getting written in an encrypted format without having any performance impact or without any knowing or any other special configuration required from the end user. So we have a video as well. It's a 5-minute video. Again, we'll point it into the resources section once you have the slides. It's a very easy setup. It just takes 5-minute stops to set up the entire environment once you have all the information ready.
Excellent. Thank you, Amit. Arun, do you have anything to add on to that? Okay. Sounds like not. Okay. One of the questions that we have here, I think, Amit, this might be a little bit more for you, but people, there's a question here about flash traffic. For instance, the most recent we know about is, Black Friday. So how does a hyperconverged infrastructure specifically deal with things like flash traffic or of that nature?
So as I mentioned that, those kind of burst scenarios are more tunable to the public cloud scenario. But the way that we are able to handle it, because you are buying the infrastructure based on your needs, and if you think that you can have that seasonal burst on your on-prem data center infrastructure, you can have some spares sitting in your network, and if you feel that you are expecting that burst, you can plug on those nodes dynamically to those clusters and utilize the peak that you would expect at the Black Friday or something similar, and maybe you can use those spare nodes and you can detach from the cluster without any disruption and put it into another cluster where you think the peak might happen at a different time. So that's the choice, flexibility, and dynamic capability that we provide as Nutanix because of our scale-out architecture, non-disruptive architecture, so that you can plug and play any nodes and scale up and down your existing infrastructure.
Excellent. Thank you. Arun, this one sounds like it's a little bit more for you. One of the questions that came up, does the encryption work, quote-unquote, live, or is it something that needs to be added manually?
Sure. So I'm going to interpret the question as, does any configuration need to occur? And so again, depending on the types of encryption you want to do, whether it's disk level or file level encryption, that's going to be different. So on the disk level encryption, what you would do is, as Amit pointed out, you'd configure the Nutanix side on Prism, and then you'd actually have the Vormetric DSM interface with the self-encrypted drives through the KMIP interface. And so that's, I guess, obviously that needs to be done manually because maybe you don't want to turn on encryption on self-encrypted drives, or you do. So it's really a function of that. And then on the transparent encryption, you basically would need to add the VTE agents or transparent encryption agent to the Nutanix cluster and then set up a policy and do the data transform. So I'd say that to answer the question is we've got tools to automate some of that stuff, but it's got to be done manually because you've got to determine which workloads you want to encrypt and how you want to manage the keys, et cetera.
Excellent. And I think you kind of alluded to this. It says, inside of Prism, can you manage Vormetric?
So I can take that question. So when I said that you can use the Prism to enable encryption for SED-based encryption, and what you can do in Prism is upload the certificates to establish the trust relation when you're talking to the Vormetric DSM. That's what you can do from the Prism itself. But from Prism, you cannot manage Vormetric device, if that was the intent of the question. So you cannot manage the Vormetric, but you can manage the setting up of the solution and uploading the certificates so that you can establish that relationship by which you can fetch the keys from the DSM.
Excellent. Okay, we're running to the end of questions, so if anybody has any final questions, please do ask them. One of the questions that we have coming in is around encryption. What are the differences between full disk encryption and file level encryption? Are there any differences between the two?
Yeah, I'll take that. So really the main difference is what is it you're trying to protect against, and that's where the distinction between the two occurs. So full disk encryption is really for theft of the media. And so if you're worried about somebody stealing the storage and being able to read that information, that's really the use case it offers. File level encryption, or let's say specifically Vormetric transparent encryption, that's really to protect against not only theft of media, but also against system level users and below. And by system level users and below, we're talking about root users, because once the disk is turned on with full disk encryption or self-encrypting drives, everybody's got access to the data. With transparent encryption, once the disk is turned on, again, you have that policy-based controls to determine, how do I to actually help reduce the attack surface from privileged OS users, so you can actually blind them from viewing data and help reduce that threat vector as well, in addition to the physical theft of the data.
Excellent. I think those were the end of our questions. So I would like at this point to close the webcast. Again, I'd like to thank all of you for joining. I'd like to thank our speakers for presenting us really good material. Again, you will get a follow-up email with the content, with a recording that you can listen to any part of this, or certainly share it with your colleagues. Again, thank you for joining us all today, and have a good rest of your day.